Welcome back, guys. So let's look at inclined plane. Right, we've done the one for a body on straight line, right? A body on a fixed rough surface. So we're looking at bodies on inclined plane. In the beginning of the lectures, we said let's assume that this is the body on a smooth horizontal, rough horizontal surface, and then this is our body, right? We said if it is moving in this direction, let's add this the applied force, right? The frictional force will be here, right? Let's call it F, frictional force. And two other forces acting on this box, let's call it a box. The weight, which of course is equals to mass times gravity, right? And the what? And the reaction, right? And then we said two things. We said if we take the resolution of force here for the x direction, so the resolution, although we know that EF of S is equal to 0 if we resolute, it's going to be EF of X is equal to this applied force, so let's call it FA minus this force. So if we do the free body diagram for this one, it's going to look like this is a positive Y, negative Y, positive S, and negative X. So if you take if we resolve all the forces to the x direction, we're going to have this force minus this force. So the applied force minus the what? Minus the frictional force. That's what we're going to have, right? And of course we know that the arrow is equal to W in this case, and W is equal to what? mg, and all of these are for body on a straight horizontal surface. But now we're looking at bodies at inclined plane. Let's assume now that this surface is inclined. So instead of it being straight, it's now inclined, right? It's inclined at an angle, right? It's no longer a rough horizontal surface, it's now a smooth surface that is inclined. At this point, what happens? You discover that this box begins to slide down. So the applied force is coming here. This is where we have our applied force, right? So let's call this our FA, applied force. If the box is coming down, you discover that our frictional force will be here, right? This becomes our frictional force because it opposes the motion, right? And we said two other forces that affect this box is the what? Is the normal reaction. These are normal reaction, and then we have the weight, right? But in reality, the weight does not come like this. Weight is always on a vertical axis, no matter how. Even if the box is bent, it's tilted, whatever it is always on the vertical axis. The weight doesn't fall on the tilted angle, it's always on the vertical axis. So this weight is just the hypothetical weight. The original weight comes down like this. This is the original weight, right? So if you look at this, you will discover that we're already forming an angle, because if we want to use this to check it, let's assume we have stuff like this, right? The free body diagram, as a matter of fact, the free body diagram, if you look at the free body diagram, it's like this. You discover that we have this as our positive Y, as our negative Y, these are what? Positive S and our negative X. And if you watch, we're already forming an angle. There's already one here, which is our weight. If you watch, that's the straight line, our weight. This angle here being equal to this angle, so it means we have an angle here like this. So if you watch, the angle is to the vertical axis, right? And I told you, if we have like the one with the classes we'll be doing before, you see that a string is pulling the box at an angle, thereby it has to form two other axes, right? So if we are having an angle here, it means we have this place forming an axis here and here. This W, this weight, we have two axes here and here. And since it is to the vertical, it's going to be W cos theta, right? Here becomes what? W sin theta, right? Because it's forming an angle here, and whenever we're having an angle being formed, it forms two axes. And since it is to the vertical, not to the horizontal, this side becomes cos theta and this side becomes tan theta. That's what it is. Just very simple. What we need to do is just to take this information and replace it here. That means this our hypothetical weight becomes W what? W cos theta here, and this place we also have another angle that is coming here. Let's just put the angle somewhere here like this. We have an angle here as W what? W sin theta. That's it, very simple. Nothing there. It's just to replace it. I said if we have our angle tilted and the bus is coming down, you discover that the frictional force goes this way, right? And if you watch from this part, we have the weight coming down. If we tilt it, it will look as though the weight is coming here, but no, weight is always on the vertical axis. The original weight is always on the vertical axis, right? It's not tilted. Weight is naturally not tilted. It's always at this point. So if we're having it at this point, it means that this weight you are seeing here, this our original weight, is forming an angle here. We said if you are familiar with trigonometry, this angle here is equal to this angle here, right? If you're very familiar with trigonometry. So if we're having an angle drawn from the free body diagram, you discover that this one now is now an angle formed, right? We're now forming another one to the vertical, and if we are forming an angle to the vertical, it means that it's forming two other axes. Here becomes what? W cos theta, here becomes W sin theta. I replace it here, I bring it here, W cos theta, and here we're having W sin theta. Remember, here we have a force before. We already have a force here. All making sense? There's already a force here, and if we want to resolve it, just when we resolve this force, if we want to resolve to the x-axis, let's assume we're having EF of x, which is equal to 0. Naturally, our EF of x is going to be what? Our frictional force minus the summation of these two forces. So it's going to look like frictional force minus the summation of applied force FA plus what? This force W sin theta. W sin theta. That's what it's going to look like. Are you seeing it now? So with this, I'm just going to let me give you two questions as regards to inclined plane. Questions that regards to inclined plane using the information I gave to you to solve problems. See you in this class, guys. Alright, so let's look at question number 1 as regards to solving questions that relates to inclined plane. It says, let's take this off. Alright. Right, it says a box of mass, our parameter, we have mass of 15 kg, mass 15 kilogram placed on a rough horizontal surface, inclined at an angle. So the surface was inclined at an angle, theta is 30 degrees, right, to the horizontal. A force of 20 Newton acts on the bus. So an applied force, let's call this FA, of 20 Newton acts on the box up the plane. Let's calculate the coefficient of friction. So we're looking for the mu. Alright, so using this information, let's use it to solve. So it said it rests on the box rests on a rough surface, and the surface is inclined at an angle of what? At an angle of 30 degrees to the what? To the horizontal. So 30 degrees. Right, and we said two things. We said that this is the hypothetical what? Wave, right? And this is our normal reaction, right? The question says the force of 20 Newton, a force of 20 Newton acts on the bus up the plane. So there's a force pushing it up. So this is our force, applied force. Therefore means that we have our frictional force here. If there's a force pushing it up, frictional force will be here, right? That's what it says. And we said if you want to use the free body diagram, we said this is the original with the real weight. And if this is the real weight, it just for me is that this is W cos theta, right? And there's another angle here, which is what? W sin theta, as I explained in the former video. This is just what you need. If you have this information, you're good to go. Very easy to solve, right? Just know this is the hypothetical weight, cos theta, the two axes, and weight sin theta. Now let's look at that. So in solving, we are looking for the coefficient of friction. Let's resolve to the x-axis. So if we know that summation of force to the x-axis is equal to 0 from the formula, from the information we have from resolution of forces, right? If we resolve all the force to the x-axis, we're going to get 0. So what does that mean? We're taking all the forces in the x-axis. Now look at, let me draw a free body diagram. It's kind of like a free body diagram here. If you watch, we have the positive x and the negative x. So, and in this x-axis, we have two things. We have the frictional force, and we have another one again, which is the what? The resolution force there. It's W sin theta. So it's going to be the force we have here, which is our applied force. This force minus the sum of these two forces. Here minus here. All of them, they are in the x plane. Right, whatever we have here minus here. So in doing that, EF of x, let me use here, EF of x is going to be what? Applied force FA minus the sum of these two forces. You're seeing there. Minus what? W sine theta plus what? Frictional force. That's what we're going to have. Remember, EF of S is 0, so solution of force, so here it becomes 0. That means 0 is equal to FA, applied force, minus what? W sine 30, because theta there is 30, and frictional force here, FF, right? So if we collect like terms, we carry everything here out. There's a minus sign here. Since it's in bracket, if we carry it out, it's going to look like this. F of A applied force is equal to what? W sine 30 plus what? Frictional force. Are you getting it? But now we know that frictional force, let me read this place off. Let's clean this place off. We know that frictional force, pardon my line, I hope it's strict. Yeah, I tried. We are aware that frictional force is equal to what? Mu r. So I can substitute this for what we have here. So if I want to complete that for equation 1, I have that applied force is equal to what? W sine theta plus what? Instead of putting the frictional force, I put UR here, the mu r. Right? Let's take it a step further. We are well aware that W alone, W is equal to mg. Right? So instead of putting W here, I can substitute mg here. I'm trying to make the equation fine now. So we have FA is equal to what? Mg sine theta plus what? Mu r. Very simple. Are we good now? So I have everything for the equation 1 just to substitute. So let's look at equation 2. We have done summation for the x-axis. Let's look at the summation for the y-axis. If you are looking for all the resolution of force in the y-axis, which is equal to 0, of course, it's going to be what? These are the two things we have there. It's going to be what? If we do a free body diagram, of course, this is a positive y, this is a negative y. Right? So we have our arrow, which is our arrow minus what? W cos theta. That's the little things we have there. So it's going to look like this. Our AF of y is going to be arrow y minus W cos what? 30. Cos 30. Right? And with that, we know that W is equal to mg. So if I arranged it, it means that 0, or we can say arrow minus what? W cos 30 is equal to 0. W is equal to mg. So I might want to say, or if I collect like terms, it's going to be that arrow is equal to what? W cos 30. So and since W is equal to mg, I can substitute by saying arrow is equal to what? Mg cos 30. That becomes what? Our m there is 15, g there is 10, right? Times cos 30, which is what? 0.8660. So if I multiply that, my normal reaction becomes what? Yeah, I have 150 times 0.8660. That's 129.9. 129.9, approximately 130 Newton. So now I have my normal reaction as R. So I'm going to substitute R for R here, right? So let's go back to equation 1. Haven't gotten the value for that. Let's go back to equation 1. Remember they gave us FA. I've cleaned that part of the board so that we can just make it seamless. Remember we have that FA is equal to what? 120 Newton, please. Correct that. It's not 20 Newton, 120 Newton. Let's correct that. So with that, FA from equation 1, let's say from equation 1, which was what? Which is FA is equal to what? Mg sine 30 plus what? Mu r, right? If we start imbibing, substituting, FA there is what? 120, which is equal to what? Mg, which is 150 because 10 mg is simply 10 times 15, that's 150. So 150 sine 30, which is times 0.5, sine 30 is 0.5 plus mu. R there is what? R is 130, right? 130. So if we arrange, it's going to look like this. 120 is equal to, this will give us 75, I believe so. Yep, 150 divided by 0.5, that's 75 times 75, sorry, my sincere apologies on that. 75. So we have 75 times 130 mu plus, sorry, it's plus, what's going on? Alright, so if we multiply this, we have 75 plus 130 mu. So if we bring it out, we have 120 by collecting like terms minus 75 to be equal to 130 mu. So if we do that, 120 minus 75, that gives us 45. So we have 45 is equals to 130 mu. So if we divide both sides by 130, this will take off this. It means that our mu is 45 over 130. If we do that, what do we have? 130. Yep, we're going to have 0.35. That's the answer. So we can therefore say that our coefficient of static friction is 0.35. That's the answer to it. So you can just go through it. The sequence that I used was very simple. I just resolved the force to the x-axis. I got this formula. If you follow the simple sequence, I say AF of s equals to F of A, this force minus everything we have here, whatever we have at the positive x, minus the sum of these two. So FA minus what we have here, right? And then you know that this is 0. We substitute and collected like terms to get this value. We got this value, right? And then I said F frictional force is equals to what? Mu R. So I began to substitute whatever it is that was needed there. So if you substitute, put them there, you have this as our equation 1. So the trick with equation 2 is to find the value of R, that's your normal reaction, the value of normal reaction. So if we use the resolution to the y-axis, it means that it's going to be everything here, positive y minus negative y, like I showed you here, positive y minus negative y. So that's what we did there, and then I collected like terms, followed the step to get the value of R, which was this, right? 130. From there, I also followed up with there and substituted whatever the value is that I need. Put the value of R and then converted and then solved till we got the final answer here. I hope you understand what we're doing, right? So in case you're having issues, you can leave the questions in the comment section, or better still, send me the question to my WhatsApp number you're seeing on the screen. Yeah, my WhatsApp number is here on the screen. Just send me the message to my WhatsApp number. I'll be sure to answer every question. Thanks to those that have been sending me messages and I've been answering, right? You can testify that I've been answering. And please, in case this is the first time you're joining this channel, make sure you like, share, and subscribe to the channel. I'll see you in the next video, guys. Thank you. Alright, let's look at example 2 as regards to forces on inclined plane. I hope my line is straight enough. Manageable, right? So it says a crate of mass 10 kg placed on an inclined plane. So the stuff is like this. We have an inclined plane, so a crate is placed on it, right, of mass 10 kg placed on an inclined plane at 50 degrees to the horizontal. So it means that we have an horizontal floor. So this is 50 degrees, right? So the place to the horizontal is acted upon by a parallel force, pulling it by a string of another suspended crate of mass 40 kg. So it means that there's a string here, right, of 40 kg at the top end of the friction by a frictionless roller. So it means that there is a roller around here. So this stuff is here, and then there's another crate here like this. That's what I'm seeing. Yep. So let's call this crate A. Let's call this crate B. Alright? Yep. So at the top of the frictional roller, find the coefficient of friction if that is that. Alright, so if this guy is pulling it this way, it therefore means that there's going to be a frictional force here. Alright? And if this is our normal reaction, this being our hypothetical weight, this being our original weight, I told you how to do that. This is W cos theta, and here we're going to have W sine theta. Please pardon me, right? Yeah, that's how it's going to look like. So the interpretation of this is that if this is what is pulling it, if this guy has a weight, right? This guy has a weight, but they give us the information of this guy that this guy has a mass, right? We are seeing a mass of 40 kilogram. The mass of this guy's mass is 10, so we can say mass of crate A is how many? 10 kilogram. Alright, and then mass of crate B is 40 kilogram. So we're having mg here, that's mg, which gives us 40 times 10, that's 400 newton. So the weight here equal to the force pulling it here. That means our applied force here, because if this one is the one dragging this one, so it is pushing this one, so the weight here is equal to the applied force that is pushing this one, and this one is coming down, this one is going like this. So the applied force, it means the applied force here is equal to that 400 newton. That's what it means, right? I'm just trying to explain how this concept works. So it's very simple. We can now get our free body diagram. What we need from here is the weight, which is equal to this force. We got our force, so it's easy for us to solve, right? If I'm looking for, I said first things first, let's take the summation of force to the x-axis, which is 0. That means EF of S is equal to this one here, that's the force here, applied force here, because we said that the applied force of crate A is equal to the weight of B, weight of crate B, right? And we did that, we got it as 400 newton. I'm trying to establish this. Always know that the applied force, in case something is given, and since this is frictionless, so we don't need anything, that becomes what? Force of A minus whatever we have here, W, sum of W sine what? Sine 50, because we said that it's 50, so here it's 50, sine 50 plus what? Plus our frictional force, right? So by right, we know what our frictional force is. We know that frictional force is equals to what? Mu r. So try to do that. We have 0 equal to, because we said summation of force at the x-axis is 0, equal to what? Force of A minus what? Minus W sine 50 plus mu r. So if I collect like terms, I bring this guy here, taking this 0 off, I'm going to have my FA as what? As W. Remember that W is mg, right? And this is the mg of this one, right? Not of this one. Mass of A. We have m of A times g sine 50 plus what? Mu r. Right? So that's for the first one. So let's call this equation 1. Right? That's for equation 1. So let's call this our equation 1. So as per minute, I'm going to take this place off and then we'll start solving equation 2. Alright, for E f of y, which is equal to 0, that's summation of forces at y, we know it's this one minus this, right? Or we can say from the first video, we said that arrow is equal to what? W cos 30, right? And we know what W is. W is mg, so we can say m of what? The mass of A, please. Ma of g cos 30. So let's finish this off. Our arrow becomes what? The mass of A is how many kilogram? 10, right? Yes. Mass of crate A is 10 kilogram. So you can come here and put there. as 10 times what? G, 10 times cos 50, not 30 please. What did I get 30 for? No, 50 please. Cos 50. So using our calculator, what do we have from there? If you have your own calculator, 10 times 10 cos 50. We do that, we have 64.27. So I have 64.27 Newton. That means our arrow, normal reaction, is 64.27 Newton. So from equation 1, alright, so from equation 1, you can say FA is equal to what? Mass M of A times G sine 50 plus what? Plus mu R. So let's substitute. By substituting, F of A is what? They gave us, we already have that as what? 400 Newton here. So we have 400 is equal to what? 10 times 10 sine 50 plus, we got the value of R as what? 64.27 mu. So it's very simple now. Using our calculator, well, let's get this. 10 times 10 10 times 10 sine 50 we have 76.60. so 400 is equal to 76.60 plus 64.27 mu. So if you collect like terms, we're going to have 400 minus 76.60, right, which is equal to 64.27 mu. By subtracting, what do we have? To have 400 minus 76.60, that gives us 323.4. 323.4 equal to 64.27 mu. Divide both sides by 64.27. This will take off this. It means that our mu will be equal to this divided by this. So 323 divided by 64.27. Yep. Answer is 5.03. Approximately 5.0. So it's very simple. You look the first video, the only thing we did that changed everything was the weight here. It's also mg. The weight, this weight is equal to the applied force there. That's 400 Newton. So if you go through it using the first the information from the first video, use it in the second video, I believe you're going to get the answer. So that's how it works. So in case you have other questions that you are finding it hard to tackle it, my number is on the screen there. Just DM me, send me a message on WhatsApp. I'll be sure to reply your message. And if you're just visiting us for the first time, please make sure you share, you like, and you subscribe. Please make sure you subscribe. Tell me what you think about the video in the comment section. God bless you. See you in the next video, guys.